Okay, so for our next topic, we're going to take a look at simplifying polynomials. And really, this is what we talk about polynomial operations. So addition, subtraction, multiplying, dividing, that type of thing. And when I look at number 13, I noticed that the first thing I'm going to work with, or the first operation I'll work with, is addition. So we need to add these two expressions, and we're just going to combine like terms. So n squared and 3n squared is 4n squared. Remember, we add the coefficients and keep the variable. Then I have a negative 3n and an n. Well, that would be negative 2n. And 14 and negative 25 would combine to make negative 11. So your final answer there is 4n squared minus 2n minus 11. Okay, so here on number 14, I have the expression 2x squared plus 3x minus 2. And from that, I need to subtract the second expression. So if you remember, we talked about how when this negative is next to a parenthesis, this is a negative 1 that needs to distribute all the way through. So I'm going to go and say, well, that means I have a negative x squared. This negative 4x becomes a positive 4x, and this negative 1 becomes a positive 1. And then I'm just going to combine like terms. So 2x squared and negative x squared becomes x squared. 3x and 4x becomes 7x. And negative 2 and positive 1 becomes negative 1. Okay, again, number 15 is subtraction. So this subtraction means I have a negative 1 that needs to be distributed all the way through the second. Problem here, so this becomes negative 8. This becomes a positive 13 and a negative 2k squared. And then we're going to combine like terms. Now remember when we write these, they really should be in order by exponent. So we're going to start with the highest exponent, which is the k squared. So I'm going to say, well, I have 2k squared, because I did not have another 2k. So that's this, and it's a negative 2k squared. So let's make sure we get that. Then I'm going to put my k's together. I have negative 8k and negative 8k. Negative 8k and negative 8k make negative 16k when I combine them. And then I'm going to combine my constants. So 5 and 13, well, 5 and 13 makes 18. So there is my final simplified form. 16. I have addition, so I don't need to worry about distributing the negative, but I do want to make sure I go in order. So the highest exponent I see is a 3. So m to the third and 7m to the third combine to make 8m to the third. I'm going to look for 2s. There we go. Negative 3m squared, positive m squared would combine to make negative 2m squared. I'll look at my m's. I have an m, so that's 1m, and negative 6m. That would combine to make negative 5m. And then my constants 6 and 11 would combine to make 17. All right, up next I have number 17. Oh, number 17 I'm not adding or subtracting. When I have a number right next to this parentheses, that means I'm going to multiply. So this is just distribution. So I'm going to distribute the outside term to everybody inside. So I'll start with 3a squared b to the third times the 2a squared. Well, 3 times 2 is 6. A squared and a squared is a to the fourth. And there's not another b, so I'm just going to rewrite the b to the third. Then I'm going to go back and distribute to the second term. 3 and negative 7 is negative 21. I would have a squared times a, which is a to the third. B to the third times b, which is b to the fourth. And then I have one more term. That's 3 times 1, which is 3. A squared, because there's only one a there. And then b to the third times b to the second is b to the fifth. So 6, a to the fourth, b to the third, minus 21, a to the third, b to the fourth, plus 3a, b to the fifth. All right. Number 18. Well, number 18, I see I have parentheses, and I need to distribute. I also have this negative, which means I have a negative 1, which also needs to distribute. So let's start there. 8p times p squared is 8p to the third. 8p times 7p is 56p. 8p times negative 2 is negative 16p. Now I'm going to distribute the negative 1 in the second set, so negative 9p to the third and positive 2p squared. Well, now I can combine like terms. So we're going to start with the highest exponent, which is 3. So I have 8 and negative 9, so that would be negative p, or negative 1p to the third. I have a 2p squared and a 56p. That's p, wait a second here, 8p times 7p, that would have been p squared, right? 56p squared and 2p squared would be 58p squared. Okay. And then I have the negative 16p all by itself. All right, so when I distributed the 8p, it would have been 8p to the third and then 56p squared and then negative 16p. There we go. All right, so we have addition, we have subtraction, we have multiplication, and then we had a two-step problem. Let's take a look at our next set. Okay, so from 19, 20, 21, 22, 23, those all look kind of alike. Those are all binomials times binomials, right? So we've talked about that word FOIL. We could use that first, outside, inside, last. But really we just need to distribute. So let's do one together, and then you can kind of work on your own a little bit. X times x is x squared. And then x times 7 is 7x. And then we'll have negative 9x, because we got to go back and get the second term in the first binomial. And then we'll have negative 63. And then we should be combining typically those two middle ones. So this should be x squared minus 2x minus 63. Okay, and as you can see, the next 20, 21, 22, and 23 start very similar. Go ahead and pause. Why don't you work those and then come back for 24. Okay, so as we look here, we can see that we are just multiplying that first binomial into that second binomial. So there are your answers for 20, 21, 22, and 23. They kind of changed up a little bit. So like for instance, on number 20, when we combine the 8w and the negative 8w, we lose those. That's a 0. And then on number 23, when we were working, we had the a's and the b's. So be careful when you have two variables. But I want to take a look at 24 and remind you, I know we looked at exponents earlier, but really what this says is I have 2y minus 1 times 2y minus 1. It's really important that you write that out when you distribute these. So this becomes 4y squared minus 2y plus 1. Again, I'm just distributing each one, and then coming back and distributing again. We'll combine like terms. So 4y squared minus 4y plus 1 is your final simplified after multiplying. All right, looking at 25 and 26, really there's not a big difference. We just have a binomial times a trinomial, so you just need to carefully move each one at a time. So this would be x to the third plus 5x squared plus 3x minus 4x squared minus 20x and then minus 12. Now we'll combine like terms, so x to the third, the squareds go together, making an x squared, because 5 minus 4 is 1. I have a 3x and a negative 20x, so that would make negative 17x, and then I would end with my constant of negative 12. All right, try number 26. All right, so it looks like we have 2c to the third minus 5c squared minus 25c, and then minus 11. Okay. Up next, let's take a look. Up 27 and 28 change up just a little bit. We're dividing here. So 27, remember when I have a trinomial divided by a monomial, or anything divided by a monomial, we could actually kind of divide this up into 3 fractions. So I'm going to kind of do that. I'm going to be like, okay, this is like 3 fractions, and everybody divides by the same denominator. Okay, 18 divided by 6 is 3. 8 to the third divided by a is a squared, and b divided by b cancels to 1. 12 divided by 6 is 2. A squared divided by a is a to the 1, so a. B squared divided by b is just b, okay. And then my last term has negative 6ab divided by 6ab. Well, anything divided by itself is simply 1. All right, let's try the same thing for the next one, number 28. Again, I have a trinomial. I'm dividing it by a monomial. So when I have that, I'm going to just kind of divide these up, make sure that's a positive. And I'm going to divide each one individually. These are three separate fractions. So I have 3x4 divided by x to the fourth divided by x squared is x squared. We'll just subtract them. Negative 8 divided by negative 8 is positive 1. X to the third divided by x squared. Again, subtract. 3 minus 2 is 1, so that's x to the first. 40 divided by negative 8 is negative 5. And then x squared divided by x squared, well, those would just cancel out because they're dividing by themselves. All right, we just have a couple more here. We're just going to do a little bit of application process here. So number 29, the length of a rectangular classroom floor is 19 feet less than twice its width. Okay, so we need to find the area, which means we're going to multiply. So here we go. Here's my floor. It's rectangular. Here's my width. 19 feet less than 2 times its width twice, right? Twice its width minus 19. Okay, and they want the area, so we're just going to multiply. I'm going to take the width, I'm going to multiply it times the length. And I'm going to say that this is 2x squared minus 19x is my area. So I might say area equals. So capital A equals. Number 30, write an expression to represent the area of the shaded region below. Oh, shaded regions. Yes, yes. This is where we get the outside and the inside, and we take the inside out. So we'll start with the outside. So the outside, or the largest, is going to be 2x minus 3 times 4x plus 7. So let's go ahead and find that. That's going to be 8x squared plus 14x minus 12x minus 21. We'll simplify, so 8x squared plus 2x minus 21. That's the outside. Okay, now I need to know the inside. I'm going to change colors. I want to know the inside. The inside is x times x minus 1. So that's just going to be x squared minus x. And now to find the shaded, I'm going to take the top and subtract the bottom. So let's rewrite that. That means I'm going to take the outside, so 8x squared plus 2x minus 21. This is the outside. And I want to subtract the inside. So that would be x squared minus x. The important piece here is I put the outside, subtract the inside, and I don't forget to distribute this -1. So really what I have here is a negative x squared and a positive x when I distribute this over. And then I can go ahead and combine like terms. So I'm going to have 8x squared and negative x squared, which will become 7x squared. 2x and 1x makes 3x. And I don't have another constant, so it would just be -21. So my shaded area is 7x squared plus 3x minus 21. And I just want to look at one more thing with you very quick. I want to look at this really cool, use this polynomial here to write a representation here. So what I see here is I have unshaded, which is positive, and shaded, which is negative. So if I wanted to look at that, let's use a little color. This means that this would be x squared and x squared. So that would be 2x squared. I have 2 of those, right? But then I have, this is a negative x, and this is a negative x, and this is a negative x. So that would be minus 3x. And then I have these guys over here. They're even more different, right? They're what do we got here? We've got -1, because shaded is negative, so -1 and -1, which makes -2. Now we'll go back to the first one here. This is x squared. And then we have negative x, so minus x. And when I come over here, I actually have 1, 2, 3. These are positive because they are not shaded. So they want me to subtract this, right? That's what this says. So I'm actually subtracting. So this is sort of like this is my first expression, subtract my second. So again, we are going to need to distribute that -1. Be careful with that. It needs to go in. So negative, positive, negative. And now we can put them together. So I'm going to have 2x squared minus x squared. So that's x squared. -3x, positive x is going to be -2x. And -2 and -3 is going to make -5. So just looking at a different way using tiles. So again, operations, so adding, subtracting, multiplying, dividing your polynomials. I think that we do pretty well with that. Remember distribution. And I do like that, taking that shaded area out. I think that's a really important problem to kind of focus on.